Welcome to the Learning Pines YouTube. We hope this video helps.
In this video, I will explain how to connect a PT100 to a PLC. First, identify your PT100 sensor type and its wiring configuration, whether it's 2, 3, or 4-wire. Next, select a compatible analog input module for your PLC that specifically supports RTD sensors. Then, physically wire the PT100 to the module following the manufacturer's guidelines. Finally, configure the PLC software to correctly interpret the sensor's resistance values and convert them into accurate temperature readings for your application. A PT100 is a resistance temperature detector, meaning its electrical resistance changes with temperature. At 0 degrees Celsius, it has a resistance of exactly 100 ohms. For optimal accuracy, always use a 3-wire or 4-wire connection to compensate for lead wire resistance. A 2-wire connection is generally not recommended for precision applications, as it introduces significant errors from the cable's own resistance, making your temperature readings less reliable. Selecting the correct PLC input module is crucial. You need an analog input module specifically designed for RTD sensors, not just general voltage or current inputs. Ensure it supports the PT100 type and offers sufficient resolution, typically 16 or 24 bits, for precise temperature measurement. Consider the number of channels required for your application, as modules come in various channel counts, from 4 to 16 or more, to match your system's needs. Once the hardware is connected, configure your PLC software. First, map the physical PT100 input to a specific analog channel within the software. Then, select PT100 as the sensor type in the module settings. You'll need to apply scaling and linearization to convert the raw resistance values into meaningful temperature units, like degrees Celsius or Fahrenheit. Finally, implement any necessary alarm limits or control logic based on these accurate temperature readings for your process.
Thanks for watching. Consider subscribing if we helped you.